Hello, everyone. Good afternoon to another session of algorithms. The plan for today is what is the plan for today? We are going to do this is going to be the last session on dynamic programming. We'll do a worksheet and we'll do a couple of more examples. उससे पहले I think we have a couple of announcements. One, homework 5 is due on Sunday. It says March 5th. It should say April 5th. Sorry about that. Long quiz 2 is also on the same day. So somewhat consequential day, Sunday, April 5th, not March 5th. Okay. Um, let's start with the worksheet. Okay. The problem I have for worksheet is the same we had one of the problems from your homework. So I hope some of you have already seen this. Can you guys see my screen and hear my voice?
Yes, Professor.
Okay, awesome, cool. Okay, so here we are. I think this is the last problem on your homework. The goal is to find minimum weight path, and you're given a grid of numbers, and number on each cell is the cost that you want to minimize. You start at the top left corner, and you have to reach the bottom right corner. And the restriction is that you can only move to the right or to down. Okay, you cannot go up. And all right, so the first question is a warm-up, and you're given a couple of grades, and you have to figure out what's the minimum cost to go from the leftmost point to the left top point to the right bottom point. So essentially, what you want to do is you want to go from here to here. Okay. The first one seems the easiest one, so let me do that one. Okay. So I think there are two ways to go from this place. Let's say this is A and this is B. There are two ways to go from A to B. You can go right first and down next, or what you could do is you could do down first and right next. Okay, so these are two possibilities. In the first case, what you incur is 1 plus 2 plus 4. In the second case, you have to pay 1 plus 3 plus 4. Okay, this seems like the more optimal path. So I would write 7 here. I hope that's perfectly clear to everyone why 7 is the cost to go from top left to the bottom right. Okay, cool. Try the next one. So this is 1, this is 2, this is 3. So this is worksheet 9 and it should be LMS. That's where you have to record your answers. Okay. Munish, what's the deadline for the worksheet?
Uh, uh, you want to give 30 minutes, right?
Yeah, 30 minutes extra. Okay.
Okay, so deadline should be 2:40
No, I
or
need to give them 30 minutes more than the class time. So I'm gonna give them 3:45. Okay.
oh, I thought we were doing the worksheet right
Yeah,
now.
yeah, we are doing it, but let's just give them 30 minutes extra. So 3:45.
Okay, okay.
Thanks. Okay. Bhaktavar says she cannot see the
See.
worksheet on
Yeah,
LMS.
just give me a minute. I'm gonna publish it.
Okay. Okay. Cool. Just record it with yourself somewhere on your notes, okay? For now. All right. The I think most of the people already got the second one. See a few answers in the chat. Don't look there. Uh, okay. Third one. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Yeah, yeah, yeah. All right. Let me know if you're done with all three parts of the first question. Thumbs up will do. Okay. Okay. All right. Raise hand if you need more time for the first part. Zen needs more time. Zen, can we help you with anything?
नो सर बस कंप्यूटेशन में थोड़ा थे।
Okay. 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 Question one more time. Sure, of course. Let me just keep the screen so that people who are working on question one can see question one. So your input is a grid of numbers, so a two-dimensional array. And your goal is to go from the start, which is the 0, 0, top left, to the last index of the two-dimensional array, which is probably the bottom right, if you visualize it as a 2D grid. Okay, that's the goal. You want to go from the top left to the bottom right part. And the way you have to travel is you can either take a step to the right or you can take a step to the bottom. Okay, you can either go down or to the right, and each time you make a step, you incur the cost on the cell that you're going to. Okay, plus the cost of the cell that you started with, right? So that's the cost that you pay, and the goal is to incur minimum possible cost by going by taking any path you want. Okay, so you probably have like exponential number of paths, and the goal is to take the one that incurs minimum cost. Actually, that's a good question. What's the if I give you a grid which is n by n, um, what's the total number of possible paths that you can take? All right, I think we are done with question one. Zan, are we done?
यस सर।
Okay, awesome. Not implying that you are the lower bound on the time we need. All right, second part. So we want to do this via dynamic programming, which means that we have to somehow save answers for those subproblems or prefix subproblems using a two-dimensional array. So if your input is a two-dimensional array, it's pretty common that your DP state would also be two-dimensional. Okay, so DP of ij, what should DP of ij be? What should DP of ij represent? Okay, can you be more elaborate? Cost.
The minimum path sum till that point.
Right, right, right. Yeah, pretty straightforward, right? It's the cost of going from point zero zero to point ij. I hope that's what everyone was saying. Okay. Okay. So
Excuse me, sir.
yeah,
Sir, can you kindly scroll up a bit, like ऊपर वाले rules, like मेरा connection थोड़ा सा off हो रहा था, so like I
sure,
didn't read that.
sure, of
Uh,
course. Also, I think so Manish, did we put the problem statement in LMS too?
Yes, professor, rules are given.
Okay. Okay. So it's there
they're
as
given,
well.
sir.
Yeah, they are given
I
to you.
didn't. Okay, I'll check them out. Couldn't find it like that.
Okay,
So
no
thank you,
worries.
sir.
Sure. All right. So I hope that we have done. So everyone who was done with part two, I cannot see the worksheet on LMS. Fatma, try now. I think it should be. I mean, Munish did it like a couple of minutes ago. Yes, this is the same question from homework. Yeah, I just wanted to give you an extra freebie. Can anyone confirm that they can see the, yeah, people can see it on LMS. Okay, it's there. Okay, cool. Moving on. Question 3. Question 3 ka I don't want anyone to shout the answer because it's the same problem we have on homework, same example. So it's not a good idea to shout the answer there, but you can definitely ask a question if you have trouble attempting it. Okay, so इस case में your goal is you're given a grade, again slightly larger grade, 5 by 4 I think, and you have to fill up corresponding dynamic programming table. Okay, so and we have already defined what dp of ij means, right? So if, for example, we are this cell is, for example, dp of ij means that the cost of going from kind of, yeah, but मैंने 0 0 लिख दिया था, it should be 1 1 because I'm indexing numbers from 1. Okay, so it's the cost of going from 1 1 to 2 3. Okay, and the ultimate goal of this part is to find out what's going to end up being here. Okay, so the cost of going from 1 1 to 4 5.
Sir, I had a question.
Sure, Hers.
Okay, so if you're going from 1 1 to 2 3, then there's more than one ways of going to 2 3, right? So which one of the ways would you mention? Because पहले आप नीचे जा सकते हैं और फिर आप right पे जा सकते हैं, और या फिर आप ऊपर से ही नीचे आ सकते हैं बाद में. So you could traverse the rows first, or you could traverse the columns first and then.
Absolutely, absolutely. And that's the choice problem that we want to solve using the dynamic program. The goal is to minimize the cost. Okay, so you sum up the cost that you incur on the way, and you want to minimize the total cost. And you want to design a DP that would give you a path that minimizes the cost. Essentially, you find out the minimum cost in the DP, and from that table, you recover the path as well. Yes.
Okay, so minimum cost path is what we are going to take.
Right, that's the one. So remember in the first part, जो हमने यहाँ पे किया है, we could go from 1 to 2 to 4, or we could go from 1 to 3 to 4. But we prefer to going first right and then down because that costs us 1 less. Right. Okay, so thumbs up if you have partially filled up the table. At least partially filled up this table. Okay. Partially means more than one column or one row. Okay. Okay, awesome. I'm gonna take that as a significant progress. That's gonna help you fill up rest of the table as well and move on because you still have some time to complete the remaining table. Okay. 1 1 is 1. Okay, so I'm incurring the cost of the cell जहाँ से मैं start कर रहा हूँ, वो भी मैं add कर रहा हूँ. So the cost of 1 1 is 1. It's not 0. Okay, so yeah. All right, moving on. Base case. What are the base cases for starting cell, first row, and the first column? Starting cell आपने अभी बता दिया है. So the cost of 1 1 is whatever is the value of the 1 1, right? So let's say कि इसके वेरिएबल का नाम हमने नहीं रखा, right? Let's say grid का नाम आपके पास g है, okay? So this is going to be g of 1 1, okay? So what is 1 comma I? This is the ith cell of the first row. So for example, what would be the cost here? So this is 1, 3. Right. Yeah. Yeah, that is correct. So this is just the sum of G1 J, where J is 1 to I. And similarly, you will have, I don't know, K1, the first column. इसको आपने fill up करना है. Yes. Yeah. Well, before and including that element. Okay. All right. Anyone with who's stuck somewhere? Need help? No? Awesome. Brilliant. Okay, cool. I'm gonna move on. Last chance to raise hands if you have something to ask. All right. So lastly, this is the main heart of the DP, which is that you have to figure out how do you find out DP of ij recursively on smaller values of DP of ij. K is any random row. So K, यहाँ पे K is the, yeah, any row. Yeah. The first column के अंदर किसी भी row के बारे में हम बात कर रहे हैं. Okay. So any of these cells. ये यहाँ पे correspond कर रहे हैं. Okay, DP of ij. Anyone wants to venture an answer for this one? Okay. Let me just go back a bit. Someone is saying that 1i is equal to g of 1. So this is what 1i is. Can I highlight this part? It's a sum of the cells in the first row. Kind of messed it up, है ना? ये मैं undo कर सकता हूँ उसको. Okay, no point highlighting. मैं circle कर देता हूँ इसको. Okay, so any entry in the first row means that you are walking just to the right. You're not going down, right? Because you're staying in the first row. You'll take the first step, you will incur that cost. You will take the second step, you will incur that cost, and so on, right? So you incur all the costs all the way. So if you take I steps, you will have to add up I values. You just add them up, right? Okay, but wouldn't the next previous element already contain the cumulative sum of the row? So okay, जो आप सोच रहे हो वो ठीक सोच रहे हो. So basically आप ये सोच रहे हो कि instead of you're saying that dp of 1 comma I is equal to dp of 1 comma I minus 1 plus g of 1 comma I. Right. So that's a recursive way to write it down. I'm just saying that generically in the form of g, how do you write gb? Okay, but you're correct that dp of 1 comma I is dp of 1 comma I minus 1 plus the ith value in the gth table. All right, so we have to write a recurrence, and someone I think already has a recurrence in the chat. Just go and copy it from there. No, don't do it. So okay, Hashir says that it's dp of, right. Yeah, absolutely. So the way you think about this is that you look at any particular, for example, index, right? Somewhere here. And there are two ways to reach this point. You can either come from the left or you can come from the top, right? So you either came from this point or you came from this point, which means that the cost of getting here is the cost of getting here plus 2 or the cost of getting here plus 2. Okay. And we already said that this is dp of, what is it? एक रो ऊपर है आप तो it's I minus 1 comma j, और ये वाला आपके पास है dp of I comma j minus 1. Okay, so these are the two ways you can reach this point, and you should prefer the smaller of them, right? Because you're interested in minimizing the cost, and that's going to give you the recurrence for dp. I hope that's perfectly clear. Once you have the recurrence, so recurrence के लिए you don't have to, जो उसका corner case है वो आपने नहीं करना, you have to do it for I more than 1 and j more than 1. Okay, so वो corner case हमने पहले ही base case में handle कर लिया है, so वो करने की जरूरत नहीं है, just write whatever जो भी हमने discuss किया. Okay, अच्छा, what's the overall time and space complexity of this bottom of TP? ये usually
Sir, I have a question with the previous one.
क्या?
What if, can you move up to the table?
Sure.
What if, like, instead of 5 and 6, we had like 1 and 1? And what if instead of 0, we had something like 13? So wouldn't it be possible to go below the number as well to get to 2?
So जो the rules say that you, where does it say? Okay, so rules say that you can move to the right or you can move to the down, which means okay, the only way to get to this point 2 is you either come from the top or you come from the left.
So what if we went to 1, 2, and instead of 5 and 6, there was like 1 and 1, and then you go to 1, 1, then back to 2 because 0 has like a really big number.
Okay, so you go from 1 to 2 and then 2 to what?
2 to, like, maybe instead of 5, there's 1.
Okay, let's say this is 1. Okay, so 2 to 1.
And then instead of 6, there's also 1.
Instead of 6, there is 1, so you go to here. Okay.
And then to the right to 1.
Right.
And then to 1, and then to 2.
So यहाँ से आप ऊपर नहीं जा सकते. That's not allowed.
Okay, you can go up.
क्या?
Okay.
Rules say that you cannot go up. क्या?
Okay.
क्या?
Okay, thank you.
Yeah, sure. Okay, so if they were allowed, तो फिर आपके पास जो मिनिमाइजर के अंदर जो आपने 2 वैल्यूज डाली हुई है वो इंस्टेड ऑफ 2 वो 4 हो जाएंगे आपके पास. You would have to do all 4, left, right, top, bottom. Okay, but यहाँ पे you are only allowed to move in 2 directions, which means कि आपको वही 2 डायरेक्शंस कंसीडर करनी है और उनमें से जो मिनिमम है वो आपने फाइंड आउट करना है. Okay, so great. I think we are done, right? Time complexity is quite simple, so वो मैं अभी discuss नहीं करने जा रहा. Just write down whatever you think is the time complexity, okay? Any questions, confusions before we move on? Will greedy algorithm be optimal for this problem? Try कर लो उसको, but I don't think it's optimal. It's not, okay? Greedy algorithm is not optimal for. Try करने में हर्ज नहीं है. It gives you good practice, but it's not optimal. Why did the base case only include the first row and the first column? और क्या डालोगे यार base case में? I don't know, you covered the first row और first column हो गया. That seems like the base case. कुछ है आपके जहन में तो please ask away. Okay, चलो ठीक है. Let's go and do some DP, more DP. Right, at a distance हमने last time किया था. I'm just gonna give you a solution for that quickly before we do one very interesting problem regarding dynamic programming. अगर हमें टाइम मिला तो हम शायद NP completeness आज स्टार्ट कर लें. Looks like कि हमें 15 मिनट मिल जाएंगे to do that. Okay, so hang tight. All right, so this was the edit distance problem जो last time हमने worksheet में की थी. Your input is you're given two strings. You want to find out minimum number of operations to transform string A to string B. And the allowed operations are insert, delete, and replace. Each one of them costs 1, and you want to find out minimum cost, okay? Or minimum number, since each operation costs 1. Okay. All right, so here are a couple of examples जो हमने last time देखी थी. And base case was that if one of the string is empty, your cost is equal to the number of letters in the other string. Okay, so ed of I comma 0 is going to be I, and ed of 0 comma j is going to be j. अब यहाँ पे definition थोड़ी सी clarify कर लें. यहाँ पे ed of I is my pen. Cannot write it. ed of I is enable stylus as pen. छोड़ो यार क्या कर रहे हो तुम. How do I'm trying a different notes app. All right, so edf I comma 0 is the edf I comma j is the cost of transforming first I letters of A to first J letters of B. Okay, just wanted to make this distinction because this could mean, so for example, यहाँ पे first I letters would be A of 0 to I minus 1. Okay, and this would be B of 0 comma J minus 1. Okay, तो ये थोड़ी सी discrepancy है कि EDF it says I, but it means that transforming letters up till I minus 1. Anyhow, I think we might have discussed this last time as well. How do I get rid of this thing? Oh man. Yeah. How do I go to full screen again? Yeah. All right. And then we had the recurrence. Recurrence says that if I and J match, the I and Jth letters match, then I and J, EDF I and J should be EDF I minus 1, comma, EDF J minus 1. मुझे क्यों लग रहा है कि यहाँ पे गलती है? Okay, I think it should be यहाँ पे इसकी बजाय it should be A of I minus 1. से इस तरह के issues आ जाते हैं. Is equal to B of J minus 1. Okay. Instead of A of I equals B of J. All right, okay. So if this is the case, then the cost is to go diagonal. You go to EDF I minus 1 and J minus 1. If you cannot match the last letters that you care about, I minus 1 and J minus 1, which are the ith and jth letters in the strings, then you have to incur a cost. But you have to incur a cost you can incur a cost in 3 different ways. You can either replace the letter, or you could insert the letter that you want, or you could remove the letter that's unwanted. Okay, so in 3 different ways you can incur this cost, and this could mean different things for your string later on, which means that you have to take minimum of these 3 operations, possible operations at position I and J. All right, so your recurrence is this, और उसके बाद I have to somehow get rid of this. Okay. Oh no. God. Okay, ये टेबल भी हमने लास्ट टाइम फिल आउट किया था. So, but if you want to find out how do you transform string A char to string B, which is score, what you need to do is you need to follow the minimum cost value. So you have 2 here, which means that it must have come from this 2. And you have a 2 here, which means that it must be this 2. You have a 2 here. This must be this plus 1, right? This is the only way this could be reached. अब यहाँ पे 1 है. This must be this one, and this is 1, so this must be this plus 1. Okay, right? So that's the way you figure out how do you transform a string to another. That you insert this character S, उसके बाद you replace this character A with O, and that's all. That's how you get the string. Anyhow, you fill up this table using the recurrence, and your your time complexity, and the space complexity is the size of the table, and the size of the table is the size of the string A times size of the string B. Okay, moving on. This was the algorithm. All right, this is the new problem that we want to do. It's kind of special because this is an NP-hard problem, which means that there is no known polynomial time algorithm for this one, and we want to find out a reasonable algorithm using dynamic programming. Okay, so somewhat magical. Someone has a question? Oof. Let me go down chat. Is this +1 thing a general rule or just for this? This is a general rule. If so, previous slide keeper, let me just go. Okay, right. So if you have the same value as the previous diagonal value, that's where you must have come from. Okay, or it's 1 plus the diagonal value, even then you must have come from there. If it's not that, then you must have come from either the top or the bottom, and top or bottom से आए हैं तो you must have incurred a cost of 1. टॉप से आने वेल इधर टॉप से आने का मतलब इंसर्शन है या डिलीशन है, या राइट से आने का मतलब लेफ्ट से आने का मतलब इंसर्शन या डिलीशन है. ओके, विच मीन्स कि आपकी कॉस्ट 1 हुई होगी वहां पे. डायगोनल से अगर आप आए हैं और प्रीवियस डायगोनल वैल्यू इज 1 लेस, तो इसका मतलब ये है कि यू मस्ट हैव रिप्लेस्ड दैट कैरेक्टर. But if it's not, then it means that those two characters must have matched. Okay, so these are the 4 different things that could possibly happen when you are matching 2 characters. Okay, so either the previous diagonal value is the same as the current one, उस केस में आपने matching किया. If the previous diagonal value is 1 less, उस केस में you replaced a character. अगर ये 2 केस नहीं है तो फिर you must have either done 1 plus to the value at the top, or 1 plus to the value at the left, which means either insertion or deletion. Okay, these are the 4 rules which are generic for any given strings. Okay, good question. Any other questions? Okay, so we are doing an NP-hard problem. Okay, and we have seen this before जब हम greedy algorithms को discuss कर रहे थे. I think the last lecture before midterm 1 or long quiz 1. The problem is called Knapsack, and your input is a list of items, and each item is a pair of weight and value. Okay, and backpack whose capacity is given. Okay, so you have a backpack उसकी कुछ capacity है जिसको हम W से denote करते हैं, and you have a bunch of possible items each with a value and a weight. What you want to do is you want to pick up items to maximize the value. You want to pick up items with a lot of value, but you cannot go overboard your capacity. Okay, so यहाँ पे, for example, you are given 5 items, and your capacity is 6 kilograms, and you want to pick up so for example, you cannot pick everything, right? If you could pick everything, that would be great. That would give you the maximum value. इस case में जो total weight बन रहा है इन items का, that's gonna be my math 5 10 12 हो रहा है, okay, which means that you cannot pick all of them. So you have to make a choice. You pick some of them and you don't pick rest of them. And your goal is to maximize the value. This is an NP-hard problem because the number of choices is exponential and there is no polynomial way to figure out कि इस choice space को reduce कैसे किया जाए. All right, so इस particular case में I think what you could do is if you remember जब हम greedy algorithm इसका design कर रहे थे, we said that we should pick the item with the highest value over weight ratio, right? That's what we did last time, and it didn't work, right? This case me, I'm not sure it works in this particular example or not, but generically we know that it does not work. Let's see what's the solution for this one. I think you can pick the last 2 items, right? And that's gonna be your capacity. 4 plus 2 is 6, and yeah, and you get $11 worth of items, which is good value, right? Yeah. Cool. Let me ask, do we all understand the problem? Can we choose each bag once? Yes, you can only choose each bag once. There is only one item. Imagine करें कि आप कहीं पे, I don't know, museum के अंदर है, and you're looking at paintings, expensive paintings. There's only one copy of each painting. So you're, I don't know, trying to maximize your value, but you have only one van. You cannot pack the whole museum there. Okay, cool. Looks like we understand the problem. Bug me if you don't, but we move on. Before we do, does anyone kind of think of a way कि इसका DP कैसे हम कर सकते हैं? Because अब तक हमने DP वाली जो problems देखी है, this problem has slightly different flavor. So I would highly encourage you to shout out if you have anything in your mind. Yeah, that's the way we should design a DP. I mean, look at the choices. जो greedy के case में आपको करनी पड़ेंगी. You have a bunch of items and you have to, for each item, you have to decide whether you want to keep it in your bag or throw it away, right? So order तो आप place कर सकते हैं, right? DP requires you to do an order thing, right? Order तो आप place कर सकते हैं. You can, order the items one by one, first item, second item, third item. That's fine. So any hints? We compare the value and weight ratio. Value and weight ratio is a greedy thing. And DP may you go for, I mean, DP की जो optimization है ना, it's no trick. It's not a trick. It does not it's not something nice about the problem that you figure out और उसमें से आप उसको आसान कर लेते हो. What you optimize on in DP is that you say that I will not solve the same sub problem again. That's what you benefit from when you're designing a dynamic programming algorithm. Yeah, good try. Okay. Any other tries? So let me make a bad try. Okay, मैं एक bad try करता हूँ उसके ऊपर. So how do I? Where is it? Okay, I'm not liking this node snap. Anyhow, okay, so here's a bad try. Oh, I already have a good try. How can I go back? I know, don't see this. Okay. All right, so here's my problem. I given items with weights and values. So let's say I have items कि मेरे पास एक array है और इस array के अंदर I have weight 1 and value 1, and then I have weight 2 and value 2, weight 3, value 3, right? And then I have weight n and value n, okay? और उसके बाद then I have capacity. Capacity को usually you put capital W or small w. Okay, so I have to figure out what I want to store in my DP. That's we are looking for, right? Okay, so what do we want to do? So here's the bad try. Bad try is that I'm storing DPFI के अंदर the solution if I only had the first I items. Okay, so maximum achievable value up till first I items. Okay, but that will fail. That will not work. So because the thing is, let's say that you want to recursively solve this. Okay, you want to figure out DPFI based on DPFI minus 1 or I minus 2. That's not easy to figure out. That's super hard. That's not. So if this is what you are keeping as the state of a DP, solution of I is potentially drastically different from solution of I minus 1. That's the crazy part. Okay, so इसलिए यहाँ पे इसके ऊपर DP काम नहीं करेगा. DP काम करेगा अगर आप स्टेट के अंदर somehow W अपनी कैपेसिटी को भी इन्वॉल्व कर रहे हैं. ओके, बिकॉज व्हाट हैपन इज कि जब आप एक आइटम को अपने पास नैपसैक के अंदर स्टोर करने का डिसाइड कर लेते हैं, ये कैपेसिटी आल्सो चेंजेस. Okay, so you can't just say okay, which items I'm gonna keep in my DP state. You also have to say कि मेरी जो current capacity है उसको भी मैंने save करना. Okay, so DP of how do I erase this thing? Man, I am absolutely not liking this. Anyhow, okay, so what you want to do is you want to store DPFIJ, which is the same thing, the solution achievable among the first I items with capacity J. Okay, and this is going to work for us. Okay, now let's see how it does. Any questions regarding this discussion? I wanted to make this kind of incorrect solution because when you're designing solutions for problems, you cannot, it's very common to come up with bad examples or bad DP states. But it happens that वो pretty easily you get to realize कि वो wrong है. Okay, DPFI for example ये वाला जो solution है, इसके बाद जब आप उसका recursive recurrence solve करने जाएंगे, you will realize that you won't be able to figure out a recurrence for that. Okay? So you will at that point know, okay, I need to change the definition of DPFI or the state of my DP. J is not the remaining capacity, J is the capacity जिसको मैं change कर रहा हूँ. Okay, so DP of, for example, oh boy, so for example DP of N comma W is the solution I'm looking for, right? It's the so DP of N comma W says that your capacity is W and you have N items available and you have to pick the ones with the maximum value. Okay, so it's the capacity that's allowed to be used on those first N or I items. Right. Okay. So let's go and see the recurrence. So recurrence is मेरे ख्याल में जब once you know DP of IJ, you should be able to come up with the recurrence. Let's try. Okay. Let's try. So now we know what DP of I comma J is. DP of I comma J is the maximum achievable value using the first I items with the capacity of J. Okay. So how do you figure that out? How do you figure DP of I comma J based on smaller values of the first index I with or in the second index J? I have more space here, so I'm going to use this space. Okay. So I have to figure out, oh boy, DP of I comma J based on smaller values of IJs. Okay. So one possibility is at this point we have to figure out whether we want to pick the ith item or not, right? Because we have already presumably solved this problem for I minus 1 and anything smaller than J, right? So at this point you have to make a decision about the item I. Do you want to keep item I or not? There are two choices that you have, and you will have to pick the minimum of them. So it's going to be minimum of potentially a couple of things. Okay. If I at some point decide that I want to keep the item I, what is going to be my solution? If I at this point decide that I have to pick the item I. So think of the scenario कि मैंने यहाँ पे ये वाला केस कर लिया, okay? So I looked at the first 4 items और उसका solution मैंने find out कर लिया. And I am at this point, okay? I'm deciding, I'm trying to figure out कि मुझे 5th item को रखना है या नहीं रखना, okay? If I decide कि मैंने रखना है, and the capacity available to me is J, so here मेरी overall value is going to be the value of the item I, okay? I'll use that value plus value of a previous solution, okay? Oh, it should be maximum. Sorry about that. Sorry, you're right. Yeah, it's the maximum of the two. Good catch. Yeah. Okay, so it's the value of item I plus what? Plus DP of something, okay? Plus DP of what? Anyone? Which previous subproblem solution can I use here? I minus 1, yes, okay. So the I को तो मैंने use कर लिया ना, अब remaining I minus 1 items होंगे मेरे पास, yes. I minus 1 comma what? Comma J नहीं होगा, right? It's because जब मैंने ith item को pick कर लिया है, that weight needs to be removed from the available capacity now, right? I have used that capacity, है ना? अब remaining knapsack capacity is reduced. So it should be so I was given a capacity of J and I had the I items to pick from. I decide that I pick the ith item, which means I will use the value of I into my whatever my optimal function is, और जो remaining मेरा bag है उसके अंदर से मैंने I की capacity use कर ली, right? So मेरी जो capacity है that's gonna be J minus the weight of I. Yes, the weight of I. I का weight मुझे remove करना है उसमें से. Okay. Cool. So that's gonna be the first part of this max. Okay. The second part is, I think, simpler. Second case mein, first of all, is this one clear? Is this clear that if I decide to pick I in my knapsack, my value is gonna be this thing. Okay. Thank you. Oh, VI is not the same as WI. VI is the value of the ith item, and WI is the weight of the ith item. Two things are different. So, for example, first case mein this is WI and this is VI. This is WI and this is VI. Okay. W1 or V1. Okay. Cool. Okay. Does anyone want to venture a guess for the case where I decide कि ith item को मैंने pick नहीं करना? If I decide that ith item is not gonna be picked, what's gonna be my solution? So if I don't pick ith item, then I must pick items from the list 1 through I minus 1, you know? Right? So it's gonna be dp of I minus 1, comma, J. Yeah. My capacity is unaffected in this case. Right? Oh, Ahmed Jalil says we pick the I plus 1th item instead. So yes, वो हमने आगे जाके करना है, but at this point we have to decide कि मेरी DP की state क्या होगी at step ij. Okay, DP की जो state होगी, it's based on to this decision that I make कि मैंने ith item को pick करना है या नहीं करना. और उसके लिए मेरे पास दो चॉइसेस हैं. अगर मैं उसको पिक करता हूँ तो फिर मुझे उसकी कैपेसिटी रिमूव करनी पड़ेगी और उसकी वैल्यू अपने अपने स्टेट के अंदर ऐड करनी पड़ेगी. अगर मैं उसको पिक नहीं करता तो फिर उस केस के अंदर मेरी वैल्यू इज गोना बी whatever I can achieve from the first I minus 1 items and मेरी capacity remains the same. Why I minus 1? So DPFI means that you are allowed to pick items from the list 1 through I. DPFI minus 1 means that you are allowed items from 1 to I minus 1. You're not allowed the ith item now because you decide कि मैंने ith item को pick ही नहीं करना. That's the reason. Once you decide कि मैंने ith item को pick नहीं करना, your admissible items की list में से I निकल जाएगा. All right. Okay. Cool. I think this makes sense. Hopefully to everyone. Let's go and see the same equation. Hopefully, probably more clearly. Next slide के ऊपर कहीं पे. Right. So DP का नाम यहाँ पे KS है for knapsack. KS of I comma W is KS of I minus 1 comma W if you decide कि ith item को मैंने pick नहीं करना. If you decide कि you have to pick it, तो फिर it's gonna be value of I plus KS of I minus 1 W minus the weight of I. Okay. So that's the optimal substructure for knapsack, and this is what you keep in your DP state. rows, items, your rows are the items from 0 to n, your columns are the capacities from 0 to w, and your time complexity is n times w, and your space complexity is n times w. I'm gonna quickly show you how you fill up this table for the example जो हमने देखी. I think it's the same example. Okay, so first row says that your capacity is increasing one by one, but your allowed list of items is empty. There's nothing allowed. So first row will always be 0, right? There is no items जिसकी कोई value आप pick कर सकें. Okay, so first item would remain. First row would be 0. The first column says that you are gradually increasing the list of items that are allowed to be picked, but your capacity is 0 now. If your capacity is 0 and you assume that all items have positive capacities, that means that you cannot pick any of the items. Okay, I think that's a valid assumption. जो यहाँ पे state नहीं हुई problem में कहीं पे, but I think it's a valid assumption. Okay, so the first column will always have the value 0. Okay. All right, so I'm trying to fill up the second row. So second row के first cell में you are allowed first item and your capacity is 1, which means you can pick the first item. Okay, if you can pick the first item तो उसकी value आपके पास आ जाएगी and that would be 2. Okay, उसके बाद 1 2 के ऊपर you can still pick the first item. 1 3 के ऊपर you can still pick the first item or the third item, right? Which means कि आपकी value at 1 3 is gonna be 5 because you can pick the second item. Oh, okay. No, I'm sorry. This row means that you can only pick the first item. You're just increasing the capacity, which means कि first row में हर जगह आपके पास 2 होगा. Okay, second row में you are allowed second item, which is I2, और उसका weight 3 है, which means कि 3 से पहले आपके पास 2 ही होगा. 3 के बाद you can pick the second item और उसकी value आपके पास 5 होगी. So it's gonna be 2 2 5 5 5 5 5. Oh, okay. So जब आपकी capacity 4 हो जाती है उस वक्त आप दोनों को पिक कर सकते हैं, फर्स्ट आइटम को भी और सेकंड को भी. ओके, सो मी जस्ट काइंड ऑफ यहाँ पे जो हमने डीपी की स्टेट रखी है उसको कंफर्म कर लें. सो एट दिस पॉइंट dp of 2 comma 4, this is dp of 2 comma 4, right? dp of 2 comma 4 के ऊपर you have to decide whether to pick item 2 or not. Okay, so if you pick the item 2, your capacity is going to be 5 plus dp of 2 minus 1 is 1, and your capacity is going to be 4. Hang on a second, it's going to be 4 minus the weight of second item, which is 3. Okay, it's 1, right? So dp of 1 1, dp of 1 1 is 2. Okay, so this 7 is basically 5 plus 2. I hope that's clear. Okay, cool. Any questions here? So dpf 2 comma 4 is just 5 plus dpf 1 comma 1, and dpf 1 comma 1 is 2. This is slightly different, right, from the flavors of dps we have seen so far. अब तक हमने जितने भी dps देखे हैं 2-dimensional, उनमें value at a cell is a function of values at the top or to the left or उसके neighboring में ही होता है, right? लेकिन यहाँ पे you can have a huge jump. So this is 5 plus this value, right? It's the I mean, it's still previously computed. It's still solution of a subproblem that you have already solved, but it's not one of the neighboring cells. Not necessarily one of the neighboring cells. All right, I hope this is clear. उसके बाद it remains same. You decide to उसके बाद increase करने से कोई फायदा नहीं पड़ता capacity को. I think the next interesting thing happens in the next row. कहाँ पे? Okay, maybe here, I guess. I don't know. Let's see. So यहाँ पे at this point, this is dp of 3 comma 6. dp of 3 comma 6. Let's say you decide to pick the third item, which means that you add 2 to something, and that something is dp of 2. This is just 3 minus 1, and then it's 6 minus the weight of the third item. Weight of the third item is 2. So 2 comma 4. Where's 2 comma 4? 2 comma 4 is here. Oh, hold on a second. मैंने कुछ ना कुछ mess कर दिया. So item 3 का value is 3. Sorry about that. So it's 3. मुझे तो eraser नहीं मिल रहा यार यहाँ पे. This looks like an eraser, but it does not erase things. Anyhow, okay, so this is 3. 3 comma 6 minus 2. All right, 3 comma 6 minus 2 is 3 comma 4. Where's 3 comma 4? मैं क्या कर रहा हूँ यार? एक second. Hold on a second. Give me a second. मैंने mess कर दिया. Is this an eraser? It's an eraser. It erases, but it erases in a unique fashion. Okay, hold on a second. इसको दोबारा करते हैं. Getting everything. Okay, so DPF 3 comma 6 is that you decide that you're gonna pick the third item. Third item आपके पास ये है. इसकी value को मैंने weight से replace कर दिया था last time. So it's gonna be 3 plus dp of 3 minus 1, which is gonna be 2, comma 6 minus the weight of third item, which is 2, which is 4. Okay, so it's 3 comma 2 comma 4, which is 7 plus 2, 7 plus 3. Okay, so this 10 is basically 3 plus 7. All right, let's see the remaining cells to figure out what's gonna be the last row. 11. Okay, so at this point, if you want to figure out how you ended up here, it's again gonna be not that easy. Just that last time nahi tha usra, okay? You will have to decide कि this is more than the weights of the so this is more than 10, which means कि ये item 5 को आपने pick किया है, okay? So लेकिन item 5 का आप weight इसमें से remove करेंगे 6 में से आप item 5 का weight remove करेंगे 2 4. So you have to end up at 4 comma 4. इससे पहले 4 comma 4 is here. Okay, so this 11 was basically 7 plus 4. उसके बाद 7, we know how we ended up with 7 though. 7 is same as this, which means कि आपने item 4 को pick नहीं किया. 7 is same as this, which means कि आपने item 3 को भी pick नहीं किया. 7 is not same as this, which means कि आपने item 2 को pick किया है. Okay, and then what you do is you remove the capacity of item 2 from the current capacity 4, and then you figure out what the next cell is. So item 2 की capacity आपके पास weight आपके पास 3 है, तो 4 में से आप 3 निकालें तो you will end up with 1. 1 comma 1 is this item. This is more than 0, which means that you picked item 1. Did you pick these 3 items? 1, 2, and 5? Yes, you did. 1 plus 3 plus होल्ड ऑन अ सेकंड, आइटम 5 को मैंने पिक किया है, इसकी कैपेसिटी 4 है आपके पास। आइटम 2 को मैंने पिक किया है, वैल्यू सॉरी, इसकी वैल्यू 5 है। आइटम 1 को मैंने पिक किया, इसकी वैल्यू 2 है प्लस 2 प्लस 5 प्लस 4 इज 11. It is right. क्यों? We could have picked item 4 and 5 as well. That was a possibility, but this is also a possibility. We could have just picked item 4 and 5. That was a solution, but this is also a solution as far as I see it. And that's what this table says. Right? Right, Bilal? Okay, cool. Carefully go, how did we trace from the table which items we pick? So at each row, start from the bottom right corner, look at the cell right above. If the value is different, then you pick that item. Okay? If you pick that item, तो फिर उसकी कैपेसिटी आपको रिमूव करनी पड़ेगी टू फिगर आउट के नेक्स्ट आइटम कौन सा है जहाँ पे आपने जाके देखना है। सो ये 11 था, 11 वाज डिफरेंट फ्रॉम 10, तो मैंने डिसाइड किया आइटम 5 को आपने पिक किया है। ओके, फिर मैंने क्या किया, इसकी करंट जो कैपेसिटी है 6, इसमें से मैंने 2 माइनस किया जो आइटम 5 की वेट था, which gave me the next cell which was 4 4, तो मैं यहाँ पे आ गया। एंड उसके बाद फिर मैं रिकर्सिवली यही काम कर रहा था। आई चेक्ड कि 7 के ऊपर भी 7 है, 7 के ऊपर 7 है, तो फिर आई डिसाइड कि मैंने आइटम 4 को पिक नहीं किया। उसके ऊपर भी 7 था, आइटम 3 को भी मैंने पिक नहीं किया। उसके ऊपर 7 नहीं था, विच डिसाइड गेव मी एन इंडिकेशन कि आइटम 2 को मैंने पिक किया। Okay, then I find out the next index by removing the weight of item 2 from the capacity, और उस इंडेक्स में मैंने जाके देखा कि वो उसके ऊपर वाले जो आइटम, ऊपर वाला जो सेल है उसकी वैल्यू से डिफरेंट है या नहीं है। वो डिफरेंट नहीं था, तो आई डिसाइड के आइटम 1 को भी मैंने पिक किया। ओके, so it's kind of a cyclic thing, but you check the cell above you to decide कि ये वाला आपने आइटम पिक किया या नहीं किया। Can we pick item 2 and 4? देखो, table is giving you the solution जो मैंने अभी आपको बताया। ओके, can you pick item 2 and 4? You cannot, because your capacity is 6 and weight of item 2 plus weight of item 4 is 7. Right? Your capacity is 6 and item 2 and 4 combined way more than the capacity. Questions? Questions, folks? All right. Okay, so cool. What's the time complexity of this algorithm again? We saw it on the last slide, right? But what's the time complexity? Can anyone remind me? M times n. What is M and what is n? N is presumably the number of items, right? So n I'm okay with. N is the number of items. What is M? This is actually an important bit that we need to go through. इसकी time complexity is different from the remaining DP examples जो हमने अब तक देखे हैं. Okay, so it's a good idea to think about it. No one? Maybe weight. What's weight of what? You mean capacity, right? Yeah, W. That's what it is. It's N times W. It's the size of the table, and it's also the time complexity. It's N times W. Few slides back, I told you that this is an NP-hard problem. So what happened? Did we break mathematics or what? Did we find the polynomial time algorithm? What is it? What's going on? Can anyone solve this mystery? It's NP hard if we consider the minimum number of items to थोड़ा सा tricky है this one. I think we have discussed this at least a couple of times, but it's not super obvious. Okay. Is this still an NP hard problem? जो आपने solve किया. This is definitely an NP hard problem, right? NP hardness. Yeah, this is gonna be our next topic. और हम इसको Wednesday को start करेंगे. But there are many combinations of capacity. Wait. True. You're right. You guys are right. But the exact words जो आपने कहने हैं वो आप नहीं कह रहे. W can be very large. Yeah. W can be very large. So the thing is, this number W is the input. It's not the size of the input, right? Remember this discussion we had in the first week of the classes, which means that if I have 100 items and they weigh a lot, right? They weigh, for example, in terms of kilograms. I don't know if you're talking about celestial objects, and they weigh, I don't know, billions of kilograms or whatever. Okay, and I give you a capacity which is 10 to the power 20. So here this algorithm is gonna cost you 10 to the power 20, right? Which is huge. So even for, like, I don't know, I give you 10 items, or the capacity is 10 to the power 20. So the algorithm is going to cost you 10 to the power 20. Okay. Again, 10 to the power 20 was the input. It was not the size of the input. The size was the number of bits required to write down that number, right? Which means that this thing जो हमने big O के अंदर लिखा हुआ यहाँ पे asymptotic, this is not a polynomial thing. It's not a polynomial function. Okay, we just write it down here. Not polynomial. Polynomial. एक और ट्रिक ये भी है यहाँ पे कि अगर W आपके पास इंटीजर नहीं है, it's a for example irrational number, even then what's your time complexity? You can't even write down the time complexity, right? That's also a kind of a hiccup here. Okay, so if W is an integer and it's a small reasonable integer, your algorithm actually returns a kind of sort of polynomial reasonable time solution, but generically this is not true. Okay, for a real W or for a very large integer W, your algorithm is not polynomial. All right, I guess that's it. I'm gonna close the chapter on dynamic programming here. You are welcome to come up with questions regarding dynamic programming on Wednesday, so bring them. Also, just let me quickly give you a syllabus for long quiz 2. This is the end of the long quiz 2 syllabus, okay? So we started with the greedy algorithms, graph algorithms, minimum spanning tree हमने किया था, shortest path को हमने किया, और उसके बाद we did amortized analysis. We did two data structures, find union, and we did priority queues. और उसके बाद I think we jumped into the dynamic programming thing. Okay, so these are the 4 or 5 topics जो हमने किए. And send me a message, tag me on Slack. I'm gonna be more available if need be, if you need my help before Sunday. So we can meet beyond our office hours too, and you can bring the questions to Wednesday class. Otherwise we will start a new topic on Wednesday, which is going to be NP completeness, which is not part of your long quiz too. Okay, from lecture 9 to lecture 19. Lecture 20, I would say we have lecture 22 actually. Quizzes ko mila ke we have done 22 lectures. Okay, right. Wait, it is the worksheet. So worksheet के जो links हैं, that's gonna be on the course web page. GitHub का जो course web page है ना, वहाँ पे सारी worksheets के links आपको available होंगे. जो आज की वर्कशीट है वो LMS में है, उसको अभी GitHub पे मैंने नहीं डाला. We're gonna put it there tomorrow, I guess. Any other remaining questions? I'm gonna stop the recording here if you want to ask a question that you don't want to be recorded. So that's it for online folks.